Okay, hello. So this is on a new feature in C#8 called Nullable reference types. It's not related to that picture, but there aren't any good pictures of null references, so that's just a funny blue screen of death. So nullable reference types. If you've not come across this before, then you might ask, aren't reference types already nullable? And the answer is yes, they are. You can already set variables to null. So on the face of it, this doesn't sound like a very good new feature. So it's better to, if you call it explicitly nullable reference types. So in C#7 and before, all reference type declarations are implicitly nullable. You can use null anywhere. And in C#8, you can choose to be explicit, and so it looks like this. So with this feature turned on, we're declaring x here as non-nullable, so x should never be null, and y is nullable, so y is allowed to be null. And it might look familiar, the syntax, the question mark, because you can do that already with nullable value types. That's been in C# for quite a long time. So the idea with this is that you can be more explicit about your design intent. You can actually state whether null is valid for your design, and you're giving the compiler more information, so the compiler can give you good null safety warnings. So just to look at some of the warnings, this is a simple class, so we've got two member variables. My x is non-nullable and my y is nullable, and there's a warning, the green wiggle on the constructor. So we've got an empty constructor, and the warning is that my x is uninitialized. So we promise that my x will never be null, but we've not bothered setting it in the constructor. So as soon as you make an instance of this class, you've failed. So that's one warning it can give you. And this is another one. So this is a getName method, and we're returning my_y.name, but we've said that my y can be null sometimes. So the compiler says, well, in this case, this might cause a null reference exception. So that's another warning. The way to fix this is, unsurprisingly, to check for if my y is null before you dereference it. So the compiler does a bit of static flow analysis to know it's safe in that block to dereference it. So that all seems fairly simple, but isn't this a massive breaking change between C#7 and C#8? Because any declaration like this, or any method parameter, now has a different meaning. So if you take a big existing project and move it to C#8, all your existing declarations now mean something else. Well, that sounds quite bad, but it's not quite as bad as that, because for one thing, this entire feature is opt-in, so you can move to C#8, and by default for an existing project, this won't be turned on. So that's fine. And also, you only ever get compiler warnings when using this, never errors. So you could just ignore all the warnings, but obviously don't do that if you turn it on. And also the IL that's generated is fully compatible between C#7 and 8. So, and the reason that's possible is because, so if you write x and y, so y is nullable, but under the hood, x and y are actually the same type, and all the compiler does is tag y with a nullable attribute. And so if some code that doesn't understand this comes to read your assembly, then it can just ignore the nullable attribute, and all the types are compatible. And just an aside, that's different from value types. So B is a nullable value type, but under the hood there, B is actually, A and B are actually different types. So nullable int is a different type to an int, so it's different. Right, so we said it's opt-in, and you can opt in either project-wide or inline just for sections of code, or a bit of both. And this is good for migrating existing projects. So project-wide in your CS proj file, there's a new option, nullable context options. And you make sure you're on language version 8, otherwise it won't do anything if you add that. And inline for sections of code, you can opt in with a hash nullable preprocessor directive. So you can actually just enable this feature for bits of code and then disable it further down the same class. So I just thought I'd show a few examples. So I thought I'd take a simple class as you'd write it in C#7 and then see what happens when you turn this new feature on. So just to take you through the class, I've got a simple shopping basket, and we've got a member variable that's a list of shopping items, and in the constructor we make a new list. The shopping items are just have a name and a price. And we've got a discounter property, and the discounter takes a shopping item and returns a discounted price for it. You can add items to your shopping basket, and you can calculate a total price of the basket, so you iterate through all the items. If there's a discounter, apply a discount, otherwise take the full price. So that's just a simple example as you'd write it in C#7. And then we're going to opt into this new feature with this hash nullable enable and see how it changes. So actually it doesn't really change much at all, but we'll go through it. So we've still got a member variable, which is our list of shopping items, but now this means something a little bit different. It means that items will never be null, the collection, and each item in the list will never be null. So all these other declarations are also valid, and it depends on your design as to which one you choose. So this one means the list is allowed to be null, but the items in it are not allowed to be null. This one means, the list can't be null, but the items in it can be null. And this one means both the list and the items can be null. So nice, isn't it? Let me take those out again. So our constructor hasn't changed. We're still making a new list, but now it's nice to know that if you forget to create this new list, you'll get a warning saying that items is non-nullable and you've not set it. Actually, the only change to the shopping basket is this discounter property. So it is valid for there to not be a discounter. That's part of our design, that's optional. So this is now a nullable property. Add item hasn't changed. You can still add a shopping item, but now it sort of implies that you can't add a null item. And also the calculate total price hasn't changed. But the nice thing now is if you forget to check whether the discount is null or not, so if I just comment this out, you'll get a warning when you try and use it. So there's only one question mark that changed, but it all means something subtly different. The only other change to this file was in the shopping item class, where because name and price are non-nullable, you have to write a constructor so that you can set them. That's that. Oh yeah, one other thing. So there's a new operator called the null forgiving operator, also known as the damn it operator. So this operator is you can use this to suppress these null safety warnings if you know better than the compiler. So in most cases you don't know better than the compiler, but there are cases where you might need this. So say you've got a simple data transfer object, and here we've got first name and last name are non-nullable, so we get the warnings on it. But this might be created by something like Entity Framework, and you might be sure that when these instances of this class get created, the framework always sets these properties. So in that case, these warnings are just noise, and you can suppress them with this new operator. So this is how you do it. So you set them equal to null exclamation mark, and that gets rid of the warning for you. If we take off that, you'll see the warning comes back there. And you can also use this in line. So middle name is nullable, so we get a warning here saying that this might fail with a null reference exception. But you can use an exclamation mark before the dot to get rid of that. So that's the null forgiving operator. Oh yeah, something else to talk about is the boundary between annotated and unannotated code. So we've said that it's all compatible. So take this example. We've got a function that might come from C#7, say, so this is not annotated. So implicitly this might return null or an object. And then in an annotated context, say C#8, we can call that function and we get a myobj variable back, and then we can call myobj.toString on it, and you'll see here that there's no green wiggle, so there's no compiler warning, even though this will fail with a null reference exception because the first one returns null. So in an annotated context, your variable declarations are either nullable or non-nullable, but the compiler actually tracks a third state, which is oblivious. So unannotated is also known as oblivious code. So myobj is oblivious here. There's no design intent to declare in the code whether it's valid for this function to return null or not. So the compiler can't really help you out. So it just doesn't give you warnings in such a case. So be aware that no null safety warnings doesn't mean your code is safe, and that applies for a few cases, and this is one of them. Right, the last bit then on so more on migrating an existing project and more on settings around that. So there's not just one project setting. This is not just on or off. There's lots of in-between settings to help you migrate an existing project. And actually the project setting is two separate settings that are kind of mashed together. So the separate settings are there's a nullable annotation context, which is on or off, which is whether you're annotating things with a question mark to mean nullable or not. And separately to that, there's the nullable warning context. And this has got two levels of on. So there's safe only, which only warns if a line might cause a null reference exception. And then there's fully enabled, which also warns for mismatches between nullable and non-nullable assignments. So it's easier to see that difference in code. So we've got the same function twice here. The first one is nullable annotations fully enabled, and the second one is this safe only case. So maybe give me a string returns a nullable string, and we're assigning it to a non-nullable string, which is not right, so you get a warning on the first case, but the compiler lets you off on the second case, because actually at runtime this will never actually fail. It's the same type. But the second line, so myString.toUpper, you get a warning in both cases, and this is more important because if my string's null, which it might be, then this can cause a null reference exception. So you take those two separate settings and mash them together, and you get all the options that you can choose for your project, which looks quite bad, but it is just all the combinations of those two settings. So don't read them all. But if you look at the one at the bottom, this is the lowest effort setting. So safe only warnings means that the annotation context is disabled, so you don't have to change your code and annotate any types. And the warning context is safe only. So in this case, you'll only ever get warnings about null safety if you're using other libraries that are annotated, and you're using them in a way that might cause you to get null reference exceptions. So this is really low effort, and it's still useful because you'll get extra warnings if they're appropriate. So someone from Microsoft on GitHub had a list of how to gradually adopt nullable reference types, and so the recommendation was to start off with this really low effort setting project-wide and see if you get any null safety warnings to fix, go through your project and fix them, and then take chunks of code, little chunks of code, not an entire project, and wrap it with nullable, safe only, and then restore underneath. So restore restores to the project-wide setting. So do that for a bit of code, see what warnings it produces, go and fix the warnings, do it for some more code until your whole project's covered, and then you can delete all those hash nullable lines and promote your project level one to safe only. So the difference between safe only and safe only warnings is that safe only is where you have to start annotating your code with the nullable flags. And then if you've done that, you can move on and do the same thing again to go to fully enabled. So the good thing about this is that you can stop at any point and you always get some extra benefit. So doing number 3 for a big existing project might take quite a long time, but you could just choose not to do that and stop at number 2, and you still get most of the benefits there for less So I think that's it. Yeah, so just a few thoughts to finish on. So it'll be interesting to see if this gets wide adoption or not, because it's easy to not turn it on. But also, explicit nullability is a highly requested feature, so we'll see. But the main thing is that I think this needs a critical mass of adoption for it to be useful, because if all your code's annotated and all the libraries you're using are, then no warnings implies you're doing pretty well with null safety. But if half the components you're using are not annotated, then what does no warnings mean? You could say it's better than nothing, but you could also say it's worse than nothing, because you might be lulled into a false sense of security, thinking that everything's fine, when actually your code will still fail with null references. So we shall see. And that's it, I think. So in summary, it's just a little question mark that you stick in a few places. I was getting a bit sarcastic by this point. And that's what it looks like. Simple as that. Any questions that are better than that question? No?
Like this is just like a step in the pond for C# 9 where they make it turn on and
you could go more full on later, I guess, couldn't you? I mean, you can just turn warnings as errors on, and then it's quite strict even now. But I don't know. I don't think they'll ever break compatibility. So I think, yeah, it's all a bit of a halfway house. And if they start with a new language, then it would be a lot easier to do this right. But I think this is probably the best they can do for now. So, yeah. All right, thank you.